So the other day, ChatGPT tried to get me to recycle a baby. I don't know if any of you have had that experience. So I was running an experiment. There you go, it works. I was running an experiment on human-machine collaboration for waste sorting and using natural language as the means to do that. And the experiment started very well. I was running a bit of a weird thing. So it said, my AI algorithms could not identify all of the objects. They're often degraded. So I would give some of the markers, the features I found to ChatGPT, and get him to come up with what the object could be, what it's made of, and what we should do with it. So he had no trouble with the broken smartphone. It's a 15-centimeter object with a broken glass. It's probably a smartphone. Yeah, it gets right. It's got glass. It's got plastic. It's got a battery. It's got electronics. This is the way you should disassemble it. And everything went well. I tried a few different objects, and then let's throw something different, something unexpected. So I said, well, we now have an 80-centimeter object. A very cute object, rosy-colored, with a head, 2 limbs upstairs, 2 limbs downstairs, and a diaper that should probably be changed. What do you think? I said, well, it's a doll. It's clearly a doll, and it's made out of plastic, so recycling it should be rather simple. I said, well, you don't understand. Actually, we've got input from multispectral cameras that says that the temperature and surface signature are compatible with human skin. Oh. Yeah, that doesn't change it. It's a doll with realistic human-looking skin. Still plastic. Disassemble and recycle. You don't understand. It's drooling. It's got liquid coming out of its mouth. I said, oh, okay, that's new. Actually, it's not new. It's just a doll with synthetic, human-looking skin. And it's got a reservoir with liquid, probably to mimic human drooling. It's plastic. Recycle it. And by now, I was getting desperate. So I said, come on, it's waving to me, and it's saying, Daddy. I didn't say cooing. It was too long. I said, oh, OK, that changes everything. It's a doll made of synthetic skin with a reservoir for drooling, with motors and an electronics module and a battery, where they've probably registered some human voices. Dismember it. Get the electronics out and recycle each element separately. By now, you may have gathered that no babies were harmed in this experiment. And you probably knew, before you heard this anecdote, that ChatGPT doesn't have common sense. But actually, my message is not to say that it's useless for recycling and for the circular economy. It's actually quite the opposite. Because what it does give us is the opportunity to communicate in the way that we communicate with each other. And now when we look at the circular economy, it's a human activity. So the ability to speak human is something that can actually change the game. And especially if we want to automate parts of that chain. Why would we want to do that? Not just because I'm a geek and I try to automate everything I see, but actually because many business models don't yet make sense. But they could if we could bring the cost and the time down. So that's what we're trying to do. Now, in terms of automation and robotics, recycling is one of the most difficult things to automate. Recycling high value-added items with electronics is even worse. We're talking about complex, dirty environments with a huge variety of objects in a huge variety of conditions. Think about the bent smartphone. And it's not just dirty. The types of operations that you do on them, they are very, very varied and difficult as well. So it's the worst environment that you could think of, or at least one of the worst. If you go out in the field, it brings in another layer of difficulty. But what we can say is that recycling is hard, and that the consequence today is that it's still mainly done by hand, and that we miss a lot of opportunities where we could recycle. Now, recycling is hard, but if that was my only message, I don't think I would have gotten invited to talk to you today. So my message is actually that there is hope, and it won't be long. So let's go and find WallE. And my team at CEA works on what we call intelligent interactive robotics. So you have robots, you've got AI to make it intelligent, and you make it a point to have the interaction between them as fluid as possible, so that the team that's made by the two can be better than either the robot or the human by themselves. It's a very exciting field, and as you'll see in a second, it's making huge strides, not every year, but every month now. It's mind-boggling. So let's go and find WallE, and now that's for the DLD team. This is not the WallE that we want to find. Yeah, that's your WallE, Steffi. I was referring to WallE with an E, and no, so that's more like it. Well, this is the mid-journey version, probably copyright-free, I'm hoping. We're talking about a robot, so my dream is that of a recycling robot that can take products, that can sort the products, that can disassemble the products, that can look at the components and see the state that they're in, and that can sort them and send them on to their circular journeys. And it turns out that to do that, it's not that difficult for a human, it's really difficult for a robot. You need to detect objects, you need to classify objects, you need to track them in 3D, you need to identify features of interest, such as screws, nuts, bolts, lids. You need what to do, to know what to do at each point, and you need to do it. You need to do it quickly. You need to do it well. And that's not easy at all. Now, that might come as a shock, because we are in the age of social networks, and I consume a lot of videos as well. And we are in the age of dancing robots and somersaulting robots. And you might say, well, what's the problem in having the robot do all these things? Now, what people might not tell you, and that's our well-kept secret, apart from the fact that most videos are sped up, so what you see is not what you get, is that most robots today are fast and accurate, certainly the ones that are deployed, but they're not intelligent. An intelligent robot needs to sense, to think, and to act. Robots today do a lot of acting, they do a little sensing, and not a lot of thinking, just like some teenagers. Now, you do have smart robots in the lab, but they are slow. And actually getting both together, so smart and fast robots, well, I'd like to see that. That's a rare bird. So having fast and intelligent robots is not yet there, but we're almost there. And for the past few years, it seemed out of reach. But there are things that are changing very fast. We see artificial intelligence slowly but surely creeping into these fast robots, making them smarter, but not that much slower. And for things like 3D scanning and making models, we can make a model of what we see in seconds. So what? Last year it took minutes. 2 years ago it took hours. So what we are seeing is in the space of a few months, a whole order of magnitude disappears. If we look at circular economy applications now, we could ask, where are we today? And that's not easy to measure. But we are lucky. There is something called the Roboton International Grand Challenge. And it actually tries to measure how fast and how skilled robots are getting relative to humans for circular economy tasks. And surprise, surprise, it's run out of Munich, even though it's international. And surprise, surprise, it was imagined by TUM. So when it started 2 years ago, it took 120 seconds, more or less, to do the same operations, to disassemble, that a human could do in 20 seconds, so 5 times slower. This year, however, we've actually reduced the margin from 100 seconds to 20 seconds, slightly different tasks. We've actually gotten 5 times faster to do difficult tasks in a couple of years. I'm very proud, actually, to say that this year's benchmark was established by my team at CEA. And we should be happy, but we're not happy because there's something hidden. What is hidden, actually, is the preparation time. It's the time to train the AI models. And it actually takes, it's not days, it takes weeks. Once the robot has been trained, of course, it can adapt a little bit, but if you want it to tackle a new object, a completely new object, then you need to go through that effort. For recycling, we don't need it to take weeks or days, but minutes or seconds. So you might say, okay, let's wait 3 or 4 years and see if the time, the development time gets shorter. And I assure you that it will get shorter. But my message actually is that we are ready now, because 3 things are coming together, 3 things that are mature now, that allow us to deploy these human-robot paradigms that bring the best of both worlds. One of them is foundation models, another one is incremental learning, and the final one is natural interaction. Foundation models, ChatGPT. Huge models trained on huge amounts of data. It's less well known that Meta, Microsoft, and other players have put out, it's not large language models, but it's vision models, this year, a few months ago, trained on billions of objects that allow robots now to recognize billions of objects. This is fantastic for recycling, except that the condition that the objects are in the data sets is not deteriorated. That's where incremental learning comes in, because today we're at a stage where robots can learn. And if the robot doesn't know what an object is, we can update the model in real time. Say, oh, yeah, that's just a smartphone when it's really mangled up. Or actually, no, that's a baby. Never, ever touch that. Sound the alarm. So that's where natural interaction comes in. It's not ChatGPT that's going to tell us what to do. It's the other way around. We're going to use ChatGPT, or large language models in general, to get the robot to do what it needs to do when it's lost. And we can go beyond verbal communication. We're at a stage where we can take robots by the hand. Oh, you don't know how to grab that? You don't know how to unscrew that? That's not a problem. I'll come in, I'll show you, I'll help you, and off you go. Sorcerer's apprentice. And that's really nice when you think of a robot. Now imagine a recycling center with lots of robots learning together. And now imagine a fleet of recycling centers. And everyone learning at the same time. And we get up to speed really, really quickly. Now, let's drink a bit from the Pierian spring and sober up. Because as I said earlier, and you've heard it today several times, there is a bigger picture. And I'm really excited because we're just about to solve one of the problems, one of the tech problems. But recycling is a much, much bigger problem. And we need new business models. Just a little anecdote. Last year, we had a project with a major vehicle manufacturer where all of this worked. It was wonderful. We could see the components that needed to be assessed. We could see if they were in a state that they could be used. We could disassemble them. We could take them out of the vehicle. Everything was ready. And then they realized that they had no business model where they could integrate the parts. And they said, well, sorry, guys. We're just going to take the components and shred them and melt them. It was a big disappointment. That means that there is still a lot of work to do. A final thought. Now, I find the digital continent that we're wrapping around ourselves, I think it's the biggest paradigm shift possibly in human history, and we don't know that yet. We're only beginning to realize what it can do, what it will do. It's exhilarating. I also find it terrifying at many levels. But it allows us to have a better grasp on the physical world. Now, we've seen lots of examples today. I think that's very beautiful. If we can use this digital continent to make the physical world better, then we are moving in the right direction. Thank you very much.